Hi, in this slide, as you see, we're going to see some wires, okay? So this is over here, the first wire is a normal wire, as you see here, okay? This is a normal wire, okay? Here we have unconnected wires. When you find two wires like this, okay? Two wires like this means unconnected wires. Of course, you will find these wires in circuit diagram and device schematic, okay? We will see in the next slides some schematic, okay? So this is unconnected wire because here we don't have any sign here. But for this is a connected wire. Why? Because we have in the middle of this two line a circle. This circle means there is a connection, okay, between this wire and this. But for this, no. Okay, so this is unconnected wire and this is connected wire. Okay, here this is the symbol of a test point. We have here a small circle in the end of this line, means this is a test point, okay? For this is the same logic or same principle as this, as you see, okay? The same principle. So this is unconnected wire. Also, this is another presentation of unconnected wire. So this or this, when you find this shape or this means it is unconnected wire. Okay? So let's go to the next slides. Over here, we're going to see some ground symbols and inductor symbols. So as you see, for those three, this is the ground symbols. Okay, we have three types of grounds. This is for this is earth ground, okay, earth ground, okay, and this is the chassis ground, okay. So this is the chassis ground. So let's erase this. Okay, so this is the chassis ground and this is the digital ground. Okay, so there is three kind or three types of ground: earth ground, chassis ground, and digital ground. So for this, the digital ground, we find it in the motherboard. For example, in the computer motherboard or the smartphone motherboard. Anyways, we find it with the integrated circuit IC, okay, or with MOSFETs, etc. Okay, so this is the symbol. This symbol is for open inductor. So this is the normal symbol for inductor. Okay, but this symbol exactly is for open inductor. Okay, and this with these two lines means iron core inductor. Okay, this is iron core inductor. Okay, so let's pass to the next slide. Over here we have some capacitors. So this is in blue color. We have some fixed capacitor, as you see. So this is fixed value capacitor. Okay, we can call this a PF capacitor. Okay, we can call it a PF capacitor. This is PF capacitor, and this is another capacitor. These two capacitors are not assigned plus or minus. It's not a polarized capacitor. Okay, so but for those, as you see, we have here plus sign. Okay, so this is a polarized capacitor. Why? Because here we have plus and here we have minus. Okay, so here with this arrow, as you see, this is a normal capacitor. exactly like this one, but here we have another arrow over here. This arrow means this capacitor is variable. Okay, so as you see, variable capacitor. Okay, its value is variable. So here we have also another sign exactly like this one. So this is variable capacitor V. Okay, variable capacitor. Okay, anyway, for this one, this is, if we put here plus and minus, it's not, this is not a capacitor, but this is a battery. For example, we can find here, for example, 12 volts. Okay, so this is a battery. Here we're going to see some switches, okay, because there is a lot of types of switches. There is some normal switches, there is other complex switches. So let's see the switch right now. So for this is a normal switch. As you see, we have here a normal switch. We have a pole, this called a pole, and we have a true here. This is a true over here. Okay, so this is a normal switch. Okay, and we have another switch with double true. Okay, this is the first and this is the second. So we have the first true and the second true, and we have a pole. This is a pole. Okay, so this is a single pole double true switch. Okay, this, for this also the same principle as this. Okay, the same principle as this. We have one true, just one true, and we have one pole. Okay, over here we have two, as you see, this is two poles. Okay, this is the first and this is the second, and we have just one true. Okay, so this is double pole single true. Okay, double pole single true. So this is a double pole. Okay, D P and single true. Okay, so this is a double pole because we have two poles over here and we have just one true, because even if we have here two true but just one true, because we don't have here the options. Okay, and here, as you see, if we focus here, this is the switch exactly like this one, as you see here. Okay, and this one. Okay, so as you see, we have SPST, single pole single true. Okay, exactly like this one, single pole. Okay, single true. Okay, so this is the single pole single true toggle switch. So this is a toggle switch, and for this we have single pole, as you see, SPDT, single pole because we have just one pole and we have two true. Okay, two state, but here we have just one state. Okay, so we have the state number one and the state number two. So this is double true, as you see here, double true. So single pole double true change over switch. Okay, and over here, this is other kind of switch. This is a push button switch. Okay, this is a push button switch. So this is, as you see, it is open. So this is a normally open, as you see, NO, normally open. Okay, this is a normally open switch. If you push it, it will be closed, but normally it is open. Okay, but for this is a push button switch, a normally closed switch. As you see, it is closed normally. So this is NC. Okay, so this is a normally closed. When you push it, it will be opened, but normally it is closed. And for this, normally open. Okay,